Well, hello. So this time we're gonna continue working on the smart contract that we started in the last video. It's kind of fun project. We're trying to build, or I'm trying to learn how to do smart contracts, and this is the first one I'm really doing. So I don't know what I'm doing most of the time. uh, yeah, but last time we started some simple smart contract and we got some few methods, and then we're going to continue. I will just recap real quick what the idea behind the smart contract is, like this specific one, what we're trying to build here. So it's called Beaver Whisperer, and that's just because I'm building it so that on my website, Beaver Codes, I can have an integration to some smart contract, and I'm going to use this one. And the idea will be kind of simple and weird, is that you will be able to kind of purchase this, let's call it token, Beaver Whisperer, and if you're the owner of the token, you can change a string value in it, which is this Beaver says here. And then on my website, I will just show it somewhere. So then, you as a buyer of this thing have the ability to what is shown on that website, basically. And the plan is to, at the end, deploy it on the Ringkaby test network so that people can actually use it without spending a real ether. Yes. But right now we're in the state where we starting to build this. So this is the constructor where we just initialize things. We have a role of creator and the owner. Creator is the person who creates the contract, because that's gonna be the person that can also destroy the contract, and I guess will claim any ether that is in that contract. And then owner is the current owner of the token. So that's the person who can change the text. And then we implemented the buy method here, where we basically check. There's one more condition we kind of arbitrarily set up, and that's that each sale of the token, the person needs to pay more than the previous person did. So we storing here how much the previous person paid, and here we're checking that the person that is trying to buy it now needs to pay more than the previous person did. And then we update the owner of the token. Well, and now we're just building this part, which is the part that changes the text, basically. So it will change this value in this field, Beaver says. So that's that. Yes. Well, we also were doing a lot of tests when we were doing this. So here in my terminal, I'm in the same folder. So here, when you see the list of files, it's actually part of the website, which is not important at this point, but later we're gonna try to put it inside the website. But there's just folder blockchain here, and here is everything. There's a contracts, which is this Beaver contract that I just went through, and there's a migration sol, and that's because I'm using a truffle tool to help me develop this and deploy and test this, and they're using migrations to kind of track some stuff. I don't really know how that works. Migrations, we're gonna do that today, I think, which is the actual deployment. But so far there's this initial migration only, which deploys this migration contract that comes from truffles. And then we have the tests, which is kind of cool. So it's in JavaScript. You have an option to write unit tests for Solidity code in both JavaScript and Solidity. They have some drawbacks, but advantages and drawbacks each approach, but I kind of like JavaScript, so that's why I'm doing this. And last time we just kind of covered the constructor and the buy function, and today we will start with this one. think we already created one test case here that should be failing now. And here we just say that if not owner is trying to buy this contract, then it's gonna fail. Because so here we kind of buy it for reals, like this will work, and then account 3 here will become the buyer, the owner of the NFT. But then we try to change the text as account 5, which is a different account than the owner, and then we expect this to fail with this message. And that expect fail here is if it wouldn't fail, if it wouldn't throw an exception, this call, then we're gonna fail the test because we expect the exception to fail, to be thrown here. And because we haven't implemented this yet, it's probably, well, it should be failing. So this is my terminal, and it's in the same folder where all the code is. And to run tests there, you just do truffle test, I think. And this will find all the tests in that subfolder tests and run them. Cool. So it did the constructor test, it did the buy tests, and then it did the set buyer test, and it failed for not owner. And yeah, because the exception wasn't what we expect. So I wanted to run it once in terminal because it's nice and you can see all the data here. But for the rest of the videos, I'm just gonna keep this integrated terminal here because this has one benefit. Well, first I don't need to switch windows, but also if I run this here, I get of course the same result, but also I get an option to click these lines and it will point me exactly to where it's failing, right? So it says I failed here, and I can see that this is where the exception is checked. Well, so now let's just go fix it. In here in the source file, we don't have any checks here, so we want to add require here. We're gonna do message sender. I guess needs to equal. I don't know if you do 3 equals in Solidity, maybe not. Let's try 2. To the owner, right? And the require is just a keyword. It's a way to, if you put in a kind of Boolean expression here or like some check that you want to check, and if that's true, then nothing happens and the code continues further. But if this is false, then it will like roll back the whole transaction and like nothing really happened, and it will put some you can optionally put the text here that will inform the caller why it failed. So we can do that. So we can say yeah, I think I had already some clever line prepared. You're not my owner, right? You can copy that. That's nice. Oh yeah, so this, I was just looking why it has this squiggly line in it, and it says function state mutability can be restricted to view. And it means that this function is not changing any state, so it could be changed to view. And benefit of having it being view, I think you just do view here, if you want to do it, yeah. So the benefit of having it view is that you don't need to spend any ether in a form of gas to call that method. You can just read it because it doesn't change any state. How that works is that it's just gonna, check your check the node that you connected to of the Ethereum network and see what's the value or what's the value in it. without needing to contact the whole network. But when you change something like a state, or what we're gonna change is this field, it needs to propagate all over the network. That's how this works, right? So yeah, but before, we haven't finished with this method, but in the end we're gonna change the state, so that's why it does make such sense to change the view. Just wanted to talk more. So now when we implemented this this require part here, hopefully the test should pass. It did not. Or what? Oh yeah, it did. What was this? Oh yeah, so it's because it's also compiling the source code every time we run the test, and it gives us the same warning here. That's fine. I already talked about that. So let's go back here, and we can add another test case, and we should do owner should be able to change text. So here we're gonna actually check the real main part of the function, that the owner can successfully change what the value of the text is. I'm gonna go a little bit way up here because I have it here. So here we're just saying from the contract, and contract, by the way, is defined here and before each. So before each test we kind of deploy new contract. That's what this notation does. So we have this contract that we kind of require, and then we're saying new, which in the context of Ethereum means, or in this framework means, that please deploy a new contract and return me instance of it. So that's what happened here. So before this test we get a fresh new contract, and we're just gonna check just to be sure, because we're gonna try to change this message. So before we do that, we're gonna check that the message is like initial message, right? Which is again defined somewhere up here, and it's dammit. Because that thing is sent to constructor when we are deploying the contract in the first place. Cool. And then the idea here is, well, let's do the same thing here. We're gonna buy it. So then we have a buyer, and then we're gonna create a variable new message here so that we can later use it for assertion. And we're gonna get it here. And here we're gonna say that the buyer is buying it. And again, we're doing async await here because all the operations with the network, they're asynchronous, because they have to be, right? It's not like an API call you do somewhere. Or it actually is an API call, I guess, but the point is that it takes a little bit of time before these things finish. And then let's do this. So after we awaited here, which if you're not familiar with async await, that would be like after we resolve the promise of this call. So that means, you know, whatever you would in then part, all the changes are done. So now we can query again what's the current status of this text here. We can call it beaver says after update. We can call this one before update. Like so. And then the one after update should now be equal to new message. So that makes sense, I guess. And now if we run this test, again, because we haven't implemented it, it should fail, hopefully. Otherwise we've done something wrong. Yes, so it did. And it's failing because the message this beaver says holds is still damn it, which was the initial message, and not the woof woof what we tried to set here. And that's because we haven't implemented it. So let's do it. And it's really simple. Like the amount of code we spend on tests is much bigger than the actual contract, which feels right because, you know, as the whole nature of these smart contracts is, it's really hard to fix the bugs after you've deployed it. You basically need to deploy a new contract and then stop using the old one. But it has some problems, like with the state of the old contract and so on. So yeah. So that's why we're writing lots of tests to cover like a small code here in the smart contract, I guess. But yeah, so now we're just gonna assign the new text here. And that should actually be all the code we need here if we run this. So this was supposed to be quite straightforward method, which is fine. Nice. It's all passing, so that's good. Let's do another one. I wanted to do like a function to test more of a way to pay out money from the contract, because remember here whenever somebody buys this is a payable method, and we're checking actually that the ether they send with this call is more than the last sale amount, so it's not zero, it's every time it's something, and we're never paying it out, so it just keeps getting pushed to the balance of this contract. So I was playing with the idea to actually, when you buy it, you will pay back to the previous owner a little bit, but then I figured let's keep it simpler, and I'm just gonna do like a claim method here. And basically the idea here is that the creator, so the person who created this, so not the owner, the creator, the first person that created the whole contract, is the only person who can claim money, and then he will get all the things that are currently in the balance at that contract. Okay. So the test for that will be a little bit difficult, but more than what we did, it's not too bad, I guess. Mostly I don't know how to write it yet, but we'll see. So we have the function. Now if we go back here, we can do another one of these ones. Why I'm encapsulating into the describe here, and this is not smart contract specific, this is just how this test framework works, is that I get this nice separation here in the result. So we're gonna do another one here, which is just describe and set claim, and then you just do another lambda function here, and inside here you can put all the tests you want. So it again should fail for not the creator. It sounds about right. Boom. And yeah, so we're gonna basically call the function. So we're gonna do await, we're gonna do await here, and then contract claim, and then we're gonna say from, I don't know, accounts to, which I hope is not the creator. Let's see, who's creator? Creator address is account 1, so that's good. and it's red here because we're using await, so we need to have a sync block here. Nice. And then we should do the same thing we've done in the previous ones where we expect the failure. Sorry. So let's do that. And here we want to expect fail again, because if we would succeed, then it's broken, and that's not what we want. And then I think it was the reason that we were looking for before, and to equal whatever. You are not the creator. It sounds alright, I think. Do exclamation mark to be consistent. Right, and when we run this, I'm just gonna hide this to make it a little bit cleaner. It shouldn't again fail because, you know, we're doing test-driven development here. It says expecting undefined to equal, which could be a little bit confusing, right? Because it's failing here. So it throws an exception, but it's still failing. So where the exception is coming from? And the exception is coming from this call. So expect fail will actually throw an exception, and we will still catch it here. That's why we making sure to compare the message as well, to make sure it's the exception that we expected, not some other exception. Like in this case, right? This is different exception. And this failing doesn't mean the test is correct, like the code is correct, because it actually isn't. Okay, going back to the test, we can do something very similar to this, I guess. The only difference is that we're gonna compare this to be creator. Yes. Well, and if we run this now, like the text doesn't match, but I want to demonstrate that it doesn't match. And then it actually gives us the correct error. Cool. So we see that the text was this, but we expected this. Let's just take this then. And put it here. Okay, so this looks good. Okay, now it's getting to the area which I'm not sure how to do, because that's not what we've done last time. But let's try to figure out. So should pay money to the creator. So let's see. So you wanna, let's buy the contract, and we're doing this so that the contract has some balance on it. We can say whatever accounts to, that's not important. And then value 10 here. Why 100 to make it easier. This is amount in ways, so not ether. That's the lowest fraction of ether we're working here with. And then how to verify it actually worked would be well, sorry, one more thing. We're gonna say creator address here. Is that we're gonna get the balance of the creator address here, right? And then we're gonna get the balance again here after that done. And the balance should change by that much. Per Well, now I'm thinking maybe it won't really, because each call of the like the claim call here will cost us some gas. So let's actually see what's gonna happen. This is interesting. How do we get the balance? I think I've done it before somewhere. No. I think we're using get balance. Okay, so let's Google for it, I guess. I think you need to use Web3 for it somehow, but let's do it. Truffle test get account balance. How do we get balance? Nice. Oh yeah, so you do this. Perfect. Hey, sorry. So Web3 is, I don't know how to describe this. Well, it's like a tool you would use to interact with Ethereum network, and it's not like truffle specific thing. It's just Ethereum thing. So even if you, when we're gonna do the integration towards our website, which runs JavaScript, it's written in React, we're gonna use the same Web3 to interact with the network as we are here. So let's do balance before claim, and then we're gonna check this, and then here we're gonna get balance after claim. Sounds good. Well, I don't actually know what these values hold, so I'm just gonna print them out right now. To see what's in there. In ideal case, the balance after should be 100 more. But I'm suspecting that calling the claim here will cost us some money as well. So let's see. Oh yeah, we actually haven't implemented that part. But it turns out I was right? We actually did get it did cost us something just to call these methods. Well, the gas, it makes sense, right? And it also turns out the numbers are way too big, which I should have thought of, to actually use just 100 to be anything good. I don't know. Well, so this is like 99 ethers, I think, right? So there are lots of zeros behind it, or not zeros. But let me think if we can. So the nice way would be to just kind of pay 1 ether, so that we get at the more significant portion here. Because it seems that we're spending on the gas way more than what we would gain by claiming 100, because that would just change like this, right? This third from right 0 to be 100. And yeah, so let's see. So what we want really is 1 ether here, which is like 1 0 0 0, 0, like lots of 0. Well, maybe we can do that. So let's try. Let's Google again. Truffle test ether conversions. No. Yes. 1 ether is that many ways. Well, okay. Okay, so they have this thing. Okay, so we can use this one. This is actually what we want, I guess. So we're gonna say this. So from 1 ether, give me way value. So yeah, exactly. And we're gonna put it down here. And it's one more thing I thought of. So let's do this. This is creator balance. And this one will be creator balance. And then we're gonna get the contract balance as well. Do you get address? Or this is the address? I don't know. Let's see. And let's call this contract balance. So one thing we definitely know that's going to happen is that expect contract balance to string. I'm going to talk about this just a sec. To equal 0. So after we call the claim here, we expect our contract balance to have nothing in it anymore, which is nice. Oh, it should fail now, right? Because we haven't implemented it and it's not working. Why we're doing toString part here is because this is not a regular JavaScript number, so you cannot compare it with 0 as a number. So this is one way of comparing this big number to something human readable, which is 0 here, is that you just convert it to string. Well, then let's try this again. Web3 is not defined. Okay. Oh, okay. Yeah, because we're doing uppercase when we should be doing lowercase. Okay, let's see. Provided address is invalid. Yes. And so I think the issue is here, because we're saying contract. I think we need to say contract address. Maybe. Let's try this. But maybe not. So let's see if this fails. We can Google again. Yeah, cool. Cool. So, and it's now failing here, right? And it's saying the actual balance is 1 ether, but you expected this to be 0. And it's 1 ether because we paid 1 ether towards it, right? So that's all good. Now we can go to code. Yes. And actually paid out. How do you pay it out? That I don't know. Let's Google again. Solidity pay contract balance. Going to answers. System payable. No, that's not a good answer. Or he actually implemented it. I guess you do transfer. Oh yeah, this might be it. Okay, well let's try this. Sorry. So instead of action here, we're gonna use the creator, which is, I assume, address. Send and transfer are only available over object time address payable, not address. Okay, well, I guess then we can make this type address payable. Is that how you do it? To expected type. Okay, well, let's Google more about this. Address payable. Oh, he has the same thing here, right? Address payable, lowest bidder, and then let's just do this. So I guess it's fine. But let's see the error here. Type address is not implicit. Yes. Well, let's find out why. I get this is quite boring because, you know, just seeing me Google stuff is not that much fun. But yeah, well, we're learning. So here it says that it separated address into address payable, address, and I don't want to use a withdrawal mechanism. When I store an address in an array in the documentation. Well, documentation is better. Do we get like address? Maybe you should read this more. It says address are the same as address, but with the additional member transfer and send. The idea behind this distinction is that under address payable is an address you can send ether to, while plain address cannot be sent ether to. Type conversion. Implicit conversion from address to are allowed, whereas conversions from address to must be explicit via payable. Okay, well, that answers it, I guess. We're just gonna do payable here. Right? And then create and transfer address of this. So this will get address of this contract, right? And then get any balance. That looks actually correct. Let's see if that works. Perfect. So it actually did. And when we look at the balances here, we can see that the balance after is actually bigger than the balance before, which is nice. Which is nice, yes. Oh yeah, so see here it says 99.905, and then we added one, so it's 100, and it would be 905, but because we spent some money, it's actually lower than that. So I wonder if in our test case, to make it more, so now the problem I'm trying to solve now is just how to compare these two to make sure they make sense. But I think from here maybe we get something in back. I don't know, receipt, and maybe the receipt would have how much money we actually spend on that, and then we can do a math and make it more better. So let's try to print a receipt here this time. Also wonder if we can, while this is running, just run one test. No, but we're running the same test. Well, the same test file. Filter. Does it have filter? Yeah, I guess you can do list, filter, list all recent stable releases from filter is specified and it will display only that type of release or Docker tags. Oh no, sorry, we're looking at build. Let's look for test. Yeah, wait. Let's go back here. So this is the receipt, nice. What did we get back? Gus used this. Does this give us option? No. Well, this is hard. Well, but anyway, we should be able to maybe just compare them and see that the creator before after claim is just bigger. Let's do that. How do we do that? So we're just gonna compare those big numbers. Let's see, is there... Let's just console log it again, I guess. Contract, no, creator balance before claim, and I guess there should be compare method on it. Creator after claim. Boom. Let's see what that does. In the meantime, we can Google if this is the actual correct thing. JavaScript, big numbers, compare. No. Big int. Oh, do you think I can do just comparison? Oh, maybe I can do just this. Let's see. Compare another function. Okay, but we can do maybe then just like compare should be lower than. Does that make sense? So now I'm thinking that maybe from what I just quickly googled, that the big int. Oh yeah, it says false here. That the current balance before claim is not lower than, oh, but it should be. Why it's not? Why is it not? Well, let's Google some more. This guy. Truffle test compare balances. How to test transfer balance of specific amount. Okay, yeah. Yeah. Expected balance, well. No, that's not it. What this documentation says. Is there anything about balance? There are some examples here, which is great. So balance, value of. Well, I guess we could call to number then. Maybe. All right. Yeah, well, let's see to number. What does the to number does? To number. I think you lose some precision when you call toNumber on the backend, but it might be fine. Let's see what it does actually. Okay, it's not a function. Alright, well that sorts things out. No, okay. Why is this hard? Why does this doesn't work? Balance value of. What is this? No. So that's much less fun. How to see solidity test check balance of account increased. How to do that? No. Instant balance call. Well, okay. I'm not gonna waste more time with this. So that's fine. We saw that the money went somewhere, and we kind of know where it went. Oh, I thought of one more thing we could do. Let's try one more thing. We could just do toString on here, right? Which we totally can, I guess. And then we could just call toNumber on it. But this is definitely not the best way of doing it. There must be a better way to compare two big numbers. But I just don't know how. Right, and then we could call like a number constructor and see what that does. So this is just pure JavaScript thing where it kind of creates a number from a string. So you should be able to get this working. Alright, so this is actually a number. Cool. So we can do number here as well. And then we have a plain old JavaScript number, and we should be able to say that this number should be lower than this number. And hopefully they are. Yes, cool. And then let's write it as proper exception, proper assertion. To be less, I don't know how to do that. Let's Google for that, but that should be easy. Chai is the testing library we're using. Expect to be less than. To be same, no. How do you do less? To be below. That's how you do it. Okay. So to be below this number. Yeah, let's see. We're gonna clean it up a little bit, I think. Oh, cool. This works. Cool. Yes. And then one more thing I wanted to do, but we don't need to write test for it, I guess. It's just Destructor. So you have there's a thing in Ethereum when you could destruct smart contract on the network, meaning you would release all the stuff and the methods are no longer callable after it. There's not such a, we don't actually need it too much, but you know, because I'm learning this, I wanted to try it out as well because it's part of it. So let's figure out how to do this. Solidity destroy, I think it's called, destroy contract. Nice. And okay, well, you just do this. But this would be very similar to the previous one, so I'm just gonna do this, that only creator can do it. No. And then we pay towards creator, right? So the self-destruct is the keyword here. It's basically the same method. Well, so maybe we should write the test for it. Well, let's just quickly copy the previous tests because it's actually very the same thing. The only difference is that after we call claim, we can still like shop around. It still works, but after we call finalize, it's not working anymore. So you're gonna say finalize and finalize. And we can write one more test case just to verify that that's true. That you should not be able to interact after. So we don't care about that, we don't care about that. Well, let's do this. Let's call finalize, and then we call like a buy thing here. And this should throw an exception, I guess. Let's try that. In the meantime, let's grep. Let's see if this fails. We're expecting exception here because we shouldn't be able to buy it after it's finalized. Whoa, it did work. Okay. Well, I guess that's fine. Oh, that's great. Well, anyways, so we have this, we have all that, it's all good. So now let's do the fun part. So now I'm thinking, let's actually try to deploy this contract somewhere. So to do this, let me just quickly commit the tests. Implementation done. Cool. So we need one of these migration scripts. It's kind of very simple. We don't need anything fancy, I guess. I don't even know what options you have here, but let's just create another file, call it, what's our file? Beaver Whisperer. And the number 2. So the way the migration is ordered is actually alphabetical. So the number at the beginning matters, right? So this one will be called first, and then this one will go. And here we're gonna deploy the Beaver Whisperer contract, and let's just call it Beaver Whisperer. Oh, I'm spelling it every time differently. Why did I choose so difficult name? I don't know. But that's cool. And then what we could do is just run truffle and deploy. But that should fail, I guess. But let's just try to do that. It tries to compile them, and it actually, something went wrong. Welcome to connect to the network. Check your network configuration. it couldn't connect to this place. So let's see where it's trying to connect to. In a truffle configs, which is a file you get when you do initialize this with truffle, there's a network section right here, and we haven't specified any, so I guess it has some defaults. But basically, we want something very similar to this. Now so right now we're just gonna try to deploy to not the ring KB yet, but to like local network that I'm just gonna run on this laptop. And one such thing we can use, it's called, I wrote it down somewhere. No, I didn't. It's Ganesh. Yes, cool. Ganesh CLI. So let's Google for it real quick. So this is a, let's see, truffle here. This is a test network with UI. There's one already baked in truffle, which is CLI, but this one is UI, and that's kind of nice. So to get it, you would just Google Ganesh, I guess, and truffle, and then you just download it. It's different for how you install it for different, operation systems. But now I have it, so I can do, UI here, and this should start a thing for us. Nice. We can do this. So it started like a local network, which is not a real network because it just runs on my laptop, right? But it created few accounts, and here's the server that it's connected to. So that's localhost, and on that port. So let's see. Going back to our config, we will put in the port 7545. We say this guy. And then, you can read here that you could specify the address that you want to deploy from. But if you don't specify any, it's just going to use account 0. So it's going to use, this one, I assume. Okay, well, so let's see what happens. So now we define that, okay, let's run it here. So let's just run it here. Now we specify the development network, and I think that's a special name. Okay, it says here. Oh, okay, so nice. So our migration here failed, and that's because we're deploying the thing, but it has a constructor parameter. When we look at it, it actually wants one text. Now, I'm not sure how you pass my arguments to constructor. My initial guess would be just send them here. Damn it. Let's try if this works. Otherwise, we will Google. Well, this looks like it worked, right? Following beaver codes, yes. We can see that we lost some money here, and that's because this account was used to do the deployment, and every interaction with network costs you a little bit of ether in the form of a gas. We can see there are 4 transactions happening. Let's see what else we can see in this window. So I'm not much familiar with this, so let's see what happens. There's some blocks, nice. Transactions. So we can see that there are 2 contract creations and 2 contract calls. Not sure why the contract calls are there. Maybe you can see more here. No, not too much. Okay, well, this is the contract. When we say the contract, we don't see anything really. But I guess created contract address, so this should be our address now. Oops, creating contract address, nice. I wonder if we can interact with it from here somewhere. Counts. Can we like sell stuff? No, possibly not. Link truffle projects, how does that work? I don't know. I need to Google more and learn about this. But anyways, it's here. It's deployed in this network. I was hoping we can figure out a way to kind of make transactions here. No? Well, let's quickly Google. Maybe here there's some tutorials, guys. Let's try one of those. Debugging a smart contract. Sure, let's try that. Okay, so you do that, you create a contract, you do the migrations, you develop, okay, you do migrate. So it's now deployed to the test network, which launches a console against Ganesh. Actually build right into Truffle. Oh, okay, so you need CLIs to do that? Oh, that's kind of not nice. Okay. Well, then maybe let's try the CLI. Ganesh CLI. This is the last thing I'm gonna try. Well, can you help me? No? No, you're just seeing stuff. Okay. Oh, it seems that it started a different thing. Or at least different accounts. Okay, well, that's a little bit sad, but it's okay. No events. Well, I guess I'm gonna leave it here. Next thing I want to do is deploy to actually a Rinkaby network where we can test more easily. Well, we can just use, MetaMask. That's a good idea. We could use MetaMask probably. Maybe we can use MetaMask to do this. So let's see. We have this thing, but I don't know how to. I think you can do custom, and then you just do 127.0.0.1. Important. Okay, well, whatever that is. Okay. Okay, I need to learn more about this before I will stream about this because clearly I don't know what I'm doing. But yeah. Well, sorry to the very bad ending to the stream, but at least we did a little bit of coding and deployed it somewhere. Next step, well, we can also deploy it to Rinkaby. That should be kind of easy because all we really gonna do is add another network here. Do they have Rinkaby? No. So you can say Rinkaby. Is that how you spell it? Who knows? And then we need to get. Oh yeah. So how this will work is we're gonna connect to local node that is connected to Rinkaby, which is gonna be a Geth client. And then we also gonna say from. And it's going to be one of the addresses in the Geth client. But for that, I also need to do some more digging and learn more about this, address. And then I can do that next time. I'm not going to bore you with more Googling me around, I think. So that's it. But the next one will be more fun, I think. We're going to deploy to Rinkaby and interact with the contract finally. Well, with that, I think I'm just gonna end it here. Well, thank you if you were watching me, and yeah, sorry for the suffering again, and have a nice Monday.